and project 4, the Flingerbot. Quick review from task 1. Propeller. So I'm going to keep my sketches simple here, but your gears that you have your rack and pinion gear that work together. And of course that pinion gear is attached to your large gear, which is attached to a small gear. And the small gear, of course, is what drives the propeller. So those are the key components of your mechanism. And you're describing the kinematics. So this here could be like your kinematic diagram. You have the, I think we call it the AP for the pinion gear, that we knew the distance, you knew the length of the rack gear. I think it's what, 6.35 centimeters, and you know your time is 2 seconds. So you can figure out, we're assuming constant acceleration. So I guess I want to actually write it this way, that the S of P is going to be your 1/2 your acceleration of P, T squared. So you can, we'll figure out what AP is there. And of course, if you know your radius, so let's identify that real quick. You got your radius of the pinion gear, you have your radius of the large gear, your radius of the small gear. So that it's spinning, so if it's rotating this way, this would be your alpha P. It's going to be the same thing as your angular acceleration of your large gear, which of course then drives your small gear. So it has that alpha S, and alpha S is of course what's driving your propeller. So just to use a different designation, I guess I'll call that alpha A, but you can figure out your alpha P is your acceleration that you figured out to the center of that gear divided by its radius, which of course you said is equal to the large gear because they're directly connected on the device itself. And so you can then say, well, the radius of the small gear and the angular acceleration of the small gear is the same as the radius of the large gear, angular acceleration of the large gear. So you can get your angular acceleration of the small gear. And once you know the angular acceleration of the small gear, then your angular acceleration of the propeller is the same as the small gear. So you have that. So you can also say, well, for the tip, we would have some velocity of the tip. For that matter, you got some acceleration of the tip. And yeah, the acceleration of the tip is your radius, the length of one propeller, and your alpha A. So you can figure out that that's a constant acceleration. So with that, you could also figure out, okay, how much did the propeller, how many revolutions did we get? I'm kind of curious as to, based on our estimate here, we can actually go back to the video and watch the, we'll call video and count revolutions. But anyway, we've got our, for constant acceleration, we've got our same relationship here, that we would have 1/2 our alpha of A T squared. So you can figure out how many radians it turns in that 2 seconds once you figure out these different gear ratios. See, figure out the velocity of the tip. You would have to know the omega. And that's really a W I wrote. So you need to know the omega. And actually, I don't want to call it A. I want T. I want to call it A. Omega A, RA. So how do we get omega? Well, omega is your alpha of A T. It's just your differential or your constant acceleration relationships for your angular velocities and your angular displacement. So any questions on task 1?
Yeah, for the angular velocity, do you want us to just have the general term for it, or when t equals 2?
Okay, you should have your general, and really what's going to be mainly gear ratios. You're going to have those general terms, and then you need to figure out, okay, what is the acceleration? Because as far as acceleration, it's going to be a constant value. But for your velocities and your displacements, it will be at 2 seconds.
Okay.
Yeah. So you got your general expression that it is a function of time based on whatever the constant acceleration value is. But then you want to figure out, okay, what is the velocity and the displacement at 2 seconds?
Will you clarify what you mean by values of all velocities and accelerations at key points on the mechanism? Like what count as key points?
So we just went over out there. Your pinion gear.
That's it?
Yeah,
Okay.
your rack gear doesn't move. So you got your pinion gear, your large gear, your small gear, and your propeller. And we'll call it the tip of the propeller.
So we need to find the velocity of each of those as well as just the propeller?
We'll call it the velocities are not really going to matter for the gears as far as we'll call it linear velocity. It's more the angular. So really you're looking at the angular accelerations of the 3 gears, angular acceleration of the propeller, and then of course your velocity and we'll call it rotational displacement of the propeller.
Okay, thank you.
So, yeah, the only things you have linear velocity, the only thing you have a linear velocity for is actually your tangential velocity of the propeller tip.